Hey guys, welcome to our lab. My name is Michelle and I work here doing something called experimental archaeology, where we like to make stuff and break stuff to figure out how it works.
And I'm Metin and I work with Michelle here in the lab, and I also break stuff. Experimental archaeology is a little different than traditional archaeology. Generally in archaeology, you think about digging artifacts up and you can study those artifacts. Here, instead, what we do is we actually recreate those artifacts, and then we use them in all sorts of ways, and we shoot them and break them and butcher stuff. And what else do we do? I mean,
all kinds of things. Yeah. We usually like to get students doing stuff hands-on, building pottery, figuring out how things work, making stone tools, even making metal tools, and then shooting them into targets to see how effective they are and how people might have used them in ancient times.
So I think today what we're going to do is do some demonstrations of how we recreate these ancient artifacts. But before we do that, we're going to walk through our lab and show you some of our equipment, which brings us to this. What is this thing, Michelle?
So this big, weird-looking machine is actually called an Instron materials tester, and that sounds very techy, and it is, but we actually use it to test how various artifacts work. For example, I could compare a stone arrowhead that people would have used in ancient times 10,000 years ago right here in Ohio. And I can compare that to a modern arrowhead that's really sharp and pointy that modern hunters use today. For example, we can put it on this machine and the machine will stab into a target material, and then it will tell us how good essentially these are at punching into a target. And so it's just useful to understand how different styles of arrowheads might have been better for certain tasks, like hunting. Some might have been better for warfare, various things that people might have used them for. And later we'll show you how we make these.
All right. And there's a lot in this room. This is just the first room out of 4 in our experimental archaeology lab. There's all sorts of equipment that we could spend lots of time talking about. But actually, Michelle, what are these as well? You're the expert.
So we have a variety of these shiny things. And these are just actually pottery kilns. We make different styles of pottery vessels, big, little, and we put them in here and heat it to a really, really high temperature, over 2,000 degrees Fahrenheit. And that turns the wet clay into a solid ceramic vessel. We even have this fancy vent hood here to suck up any fumes that might be coming out of the kiln during that process. It gets very hot.
Is there a pot in there?
There might be. I think so, yeah. I think it's a little baby pot.
Oh, it is a little baby pot.
Yeah, ooh, it's kind of warm still. But this is just an ancient replica that we made, and it's so tiny because I am looking at something very specific to see basically whether or not it's going to fall apart after that very high heat treatment. So normally we fire much more stuff in this kiln, but we have this teeny tiny little baby pot.
In a great big kiln.
Yeah.
So, all right, well, let's move on to the next room. If you go into archaeology or really any science, there's a lot of reading, and so this part of the lab is where we've got all of our books. And so we have students and ourselves. We do a lot of research in this room about how to do experiments and also different types of artifacts. And what's really neat is everything in this room is a replica artifact, whether it's stone arrowheads that I made here on the table, hafting, which is attaching a stone to a spear shaft. These are also replicas. Really well done by one of our students named Mike. The pots up on the bookshelves there are all replicas. The quiver, there's spears up above the whiteboard there. So between the books and the artifacts, this is just a really neat research room. But, all right, let's move on to the third room.
Yeah, so in this next room is where our students actually have their own workspaces. When you're an archaeology student, you are able to do a lot of hands-on things. For example, one of our students has made a whole bunch of replica pots, and we are going to fire these in that pottery kiln and then break them and maybe even cook in them and see how they perform. Over in some of the other stations, we have students who are working with stone tools, doing hafting. We have points here made out of a special rock called obsidian, and this makes a really sharp edge. Our student Mike is a specialist at hafting it and getting it attached to this shaft, which is very important for hunting.
We're not going to war. It may look like we're making all of these weapons and stuff, but it's just to learn about the process that prehistoric people would have used to make these hunting weapons. And then actually you can see some of Michelle's amazing pottery here. There's some in the other room too. She won't brag about herself, but she's amazing at ceramic technology. What's the earliest pottery that we get in the archaeological record?
Oh, pottery's been around for a long time, almost 23 to 25,000 years ago. So people have been playing with clay for a long time, and many of you have probably done it today in your art class.
So, and then I think we'll move to what I think is the most fun room.
Yeah, we'll go in the experimental room where we actually make all of these different things.
So this room is really a dream for us. We can make almost any artifact from the last 3 million years of human technology. And whether that technology is metal or pottery or my specialty, which is stone, we can make it and then we can break it. And so over here we've got woodworking, and we've got a forge over here where Dr. Beber, Michelle, makes her metal weapons and tools. Right over here is our pottery studio where Michelle will make pots. She'll also process clay. And we've got all sorts of fancy equipment to make the clay pure and workable. We have pottery wheels, which Michelle will give a demonstration of in a little bit. And then my favorite area of this part of the lab is the stone working. And I'm gonna give a demonstration of that in a bit, but you can see all of the rock that we've got here. We've got enough rock to make weapons and tools for many decades. We're really lucky, and I will really be happy to give a demonstration of making stone tools. Just give us a second to set up and we'll get going on that. So the process of making stone tools is called flint knapping. And knapping is actually a Dutch word. And what you do, well, first, before we start, let me just say you've got to be really safe when you try to make stone tools. So don't try to do this unless you have your parents' permission, all right? Because it can be a little dangerous. You always want to have eye protection when you make stone tools. That's really important because there could be sharp chips from the stone that fly everywhere. And then you also want to have a leg pad that's pretty thick. I usually use leather just to make sure that none of the sharp chips go on your leg, all right? You can take a rock like this. This is flint, all right? Or other types of rock like obsidian or basalt. They all fracture like glass. Essentially, they have a property that we call conchoidal fracture, and that's the same fracture as glass. And if you know that your rock has conchoidal fracture, you can actually break it in very predictable ways. So I'm gonna take a rock like this. This is my hammerstone, and I'm gonna hit the flint. All right, not too hard, it doesn't take a lot of power. And I get a nice, sharp stone flake. And you can see that real sharp edge. We'll show you how sharp in just a second here. I'm gonna strike another flake off. We'll go right next to the one I just took off. Just take my hammerstone. It's all about angles. There's not a lot of power involved, but you get a real nice sharp stone flake. And we think that the very first people that started to flint knap over 3 million years ago produced these sharp flakes to process meat, which would help improve their diet. Actually, Michelle, do you want to come over here real quick? Let's show you how sharp this is. Why don't you go ahead and take that flake. And this is real thick leather. And let's show you how sharp.
Ooh, nice.
All the way through, real easy. So you can imagine if it can go through thick leather like this, if you need to cut your steak for dinner, you've got no problem, all right? Now, the nice thing about flint knapping is that you can do more than just strike off flakes. Although I can strike lots and lots of stone knives off of this core of a rock, and you can see all the negative flake scars from this core, from all the flakes that I've taken off, right in a row. And archaeologists will actually find these cores and will find the stone flakes that people flaked from millions of years ago. So it's a really cool thing. Now, I don't have to just use a hammerstone, and what we see about 1.8 million years ago, people actually switched from using a hammerstone to using bone or antler to make their stone tools. And that allows you to have much thinner flakes from your rock. So depending on what type of hammer you use, you can really chip really small flakes or really large flakes. And there's lots and lots of ways to make these stone flakes. Now, I can make the stone flakes for their own sake, but I can also start to shape this rock by itself. And the advantage of shaping this rock by itself is if I want a larger tool, like an axe, for chopping trees down, I can do that. Let me also switch back and forth, get a real big flake off. You see all these little chips that are coming off? Lots and lots of chips are produced when you make stone tools, and they're all real sharp. So again, if you ever try to do this at home, be real careful. But just with a few flakes taken off, you can see I'm already starting to shape this particular rock into an axe. And this can be used for chopping down trees or anything you want to do with it. So you can make lots and lots of neat things out of stone. Now, if you want to do finer work, all right, and make an arrowhead or something like that, people actually invented ways to push off the stone flakes, and that's called pressure flaking. What I was doing with this hammerstone is called percussion flaking. Percussion like a drum, you're hitting it. Pressure flaking is when you actually push off stone flakes, and so this is a knife that is halfway done. All right. And what I'm going to do is, to make it more done, I'm going to put my pressure flaker, which can be antler or copper or something like that, on the edge. I'm going to use all my strength and push off a really teeny flake. And see, that flake came off from right there. I'll do another one. So that flake came off right next to that one. And the advantage of using a pressure flaker is that you can make really beautiful artifacts. So if I were to spend more time making this knife or arrowhead, I would eventually turn it into something like this or this. And you've got different styles of spear points or arrowheads, and different spear point styles are sometimes characteristic of certain particular prehistoric cultures. So we can learn a lot about those cultures by learning about how they made their stone tools. Now, once you've got your stone tools, you don't want to use an arrowhead just by holding it, all right? You want to haft it. And again, hafting is attaching a stone tip to some sort of handle. And in this particular case, I've attached a finished stone point that I made to this antler handle. So now I've got a safe spot to hold this handle, and now I can cut whatever dinner or meat or food that I need to make. And you don't just make small arrowheads, you can also make really large, beautiful knives. And so this is a special type of knife made in southern France and northern Spain about 18 to 21,000 years ago, made on a special chert or flint from England. So the process of stone tool making, again called flint knapping, is really useful for making ancient prehistoric weapons and tools. Now, you can make those tools and weapons not only from stone, you can also make it from metal. And I think Dr. Beber, Michelle, is going to be doing a demonstration of that. So just give us another second to set up that, and we'll be with you, and Dr. Beber will show how to make copper weapons and tools.
Hey guys, okay, so now we're going to talk about something that I'm very interested in. Metin just showed you how to make tools during the Stone Age, but my research focuses more on what's called the Metal Age, specifically looking at copper tools, which is also called the Copper Age, and bronze tools from the Bronze Age. So if you look at this copper point, you can see that there's hammer marks on it, and that's because this is one of the earliest types of metal tools. And it was made right here in North America about 8,000 years ago. And this is made in a process that I'll show you in a few minutes by simply heating up a piece of pure copper and pounding it into this arrowhead shape. Later in time, especially in the ancient Near East and Egypt, they figured out that if you heat the copper really hot, it becomes almost like a liquid, and you can mix the copper with something called tin, and then that makes bronze. So copper and tin together is what produces bronze, and that's what a lot of the ancient Greek weapons, Assyrian weapons, were made out of bronze points, just like this. So let's go over here and I'll show you really quick how easy it is to forge a copper tool. So let me put these down. So I'm going to take the piece of copper out of the forge. The good thing about using copper is that it has a fairly low heating point, and it gets hot at about 400 degrees Celsius, which is something that you could easily do in a fire. You don't need a special kiln like this. So as you can see, this piece I just brought out is a nice glowing red color, and that means it's ready for me to hammer it and start shaping it. And to do that, I simply come down here to an anvil and I just hit it a few times with this hammer. And copper is so soft that it's actually fairly easy to pound it into an arrowhead shape. And you can see it's all black right now, and that's just from being in the fire. But when I'm done, I can polish this on some rocks and get it nice and shiny and looking like a piece of copper. So let's put it back into the fire for a little bit and heat it back up. So something very interesting that happened right here in North America is we have some of the earliest copper tools in the world, some of them beginning as long as 8,000 years ago. And that's because up in Michigan, right below Lake Superior, there's a large natural source of pure copper. And I'm holding a piece of that here. And you can see a little bit of the copper coming through. It kind of looks like a penny. But on top of it is this nice green color. And that's the patina, right? That's from the copper minerals reacting with other elements in the atmosphere like sulfur. And it causes a patina to grow on here. A really good example of this is the Statue of Liberty, which you might think of as being green, right? It's very pretty. But that sculpture is actually made of copper. And it's just got that nice green color because it's grown a patina over the past century from a very similar reaction, which is pretty cool. Thousands of years ago, hunter-gatherers realized that you could take this pure copper and heat it up in a fire, just like I showed you here, and hammer it into all types of different tools. An example would be this big copper knife, which is hafted, just like Metin showed you with stone points, into an antler handle, right? So this would be really convenient for butchering or cutting up whatever it is you were going to eat for dinner. We know that they did a lot of fishing during this time, and you can imagine this would be great for filleting a fish or just, you know, cutting whatever you need to cut. Hey, Metin, what are you doing over there?
I'm sorry, I'm just looking at a pot.
All right, hold on. I'll be over there to show them in a minute.
Michelle will be doing the pottery demonstration, but her pots are awesome. I can't help it. So
all right, I gotta turn this off. Okay guys, so now we're going to talk about something that is one of my favorite things in the world, and as you can see, that is pottery. Before I became an archaeologist, I actually went to art school and studied how to make pottery because I loved it so much. So if you guys like art and you like the past, you know, experimental archaeology is kind of the perfect combination of those things. As you can see here, there's a variety of different items that have been made out of clay in the past. Clay has been used for about 25,000 years by humans to make stuff. Some of the earliest objects were figurines, like this lady shown here. She is about 25,000 years old. Other early pottery comes from China and dates to about 23,000 years ago. And that pottery is some of the earliest pottery vessels. Similar to something like this, if you can imagine, a big round pot that would have been used for cooking. So clay is something that many of you have probably used already in art class, or if you haven't used clay, you might have used Play-Doh. It's kind of the same concept. It's really unique in that it has this property called plasticity. And plasticity simply means that the material is soft and you can move it around really easy with your hands. And when you quit pushing on it, it keeps that shape. Whether it's a simple pinch pot or whether it's a really nice figurine, clay maintains whatever shape you squish it into. So it's really fun to play with, but it's also really useful. So I'm just going to show you really quickly how to make a pot similar to this. Most of the pottery in the world has been made using a very simple technique called hand building. Hand building, as you can guess, simply means building it with your hands and not really using any fancy equipment. But your hands are really awesome for making stuff. As you can see here, I'm just making a simple pinch pot. It looks kind of lumpy now, but that's okay because I have a technique for making it look nice and smooth and pretty like those ones. But to make a big cooking pot or a storage jar, all you need to do is start with a base like this. Right now it's kind of floppy, and that's okay because I'm going to set it aside and let it dry for a little bit so it firms up. And then I can keep going with the next stage of building. I made this yesterday, and as you can see, this pinch pot is nice and firm, right? I can move it around, it's not going to collapse. And that is excellent for doing something called coil building, okay? So to coil build, you might have done this already, but you're basically going to first kind of mess up the top part of your little pinch pot so that it's kind of rough, right? And then you're going to take a coil that you just roll out of clay. It's kind of like a snake. Once you have your coil, you can then just fit it nicely on top of that sort of messed up area. And the reason that you kind of just chop up the clay and make it all messy before you put on your coil is because it actually helps it bond together and stick together really well so that you get a nice sturdy pot, right? So you can see I'm just kind of squishing it on there, and I added a nice level to make my pot taller. I'm going to add one more coil. And a lot of the pottery that's made in North America uses coils that are more flat, right? You can see that this was once a round coil that I kind of just smushed to get it flatter. And if you think about it, it makes sense to build with a flat coil because you're adding a lot more height every time you put on one of these coils. So once again, I'm just messing up this top edge to get it kind of sticky. And then I'm going to put my flat coil nice and neatly on top of that, smushing it on with my fingers. Oops, get my coil out of the way. And as you can see, by adding that flat coil, I added about 2.5 more inches to my pot. Right, so all you have to do is keep adding these coils to get it as big as you want and let it firm up a little bit. And as you can see, it's still kind of wonky looking, it's not that impressive, but there's a technique called paddle and anvil, and this is a technique that people used here in North America for making their pots nice and thin and round like you normally think a pot should look. So I'll show you how to do that. All you need is an anvil, which here I'm using a rock, which is very useful. And I have a paddle with string wrapped around it. Okay, so I'm simply gonna put my anvil rock inside my pot, and then I'm going to paddle it with this wooden paddle. And look at what I'm doing, and you can see it's leaving a nice chord marking on the surface. And every time I'm doing this, it's not just leaving that pattern, but it's also giving the pot a nice round shape, and it's compressing the vessel wall and making it nice and thin. So if I keep doing this the whole way around, I will get a nice, big, thin pot that's good for cooking or storage or whatever people might have used it for in the past. And it also looks kind of cool because it has these surface marks on it. If you don't like cord marking, you could just take a wooden, this is called a kidney, but it's basically just a smooth piece of wood. And you can quickly just smooth over those cord marks. And then you could paint your pot, carve on it, do all types of things to decorate it when you're done, right? Like some of the examples over here. So we know that people have been using clay, and it's been a central part of, human lifeways for 20,000 years. They've used it for cooking, decorating, making hearth, etc. But there's one thing we haven't seen them doing with clay, and maybe you can figure out why, but they've never really used clay to make arrowheads, right, for shooting. And we're going to do an experiment here, and you guys can help us, and we're going to compare and try to figure out why they wouldn't use ceramic, even though it's really, really hard. They never used it to make arrowheads. So let's go and shoot something and see what happens. Here is that ceramic arrowhead that I made out of clay. And here's also a copper arrowhead that I made also.
And this is one out of stone that I made. And I think while we make lots of stuff in this lab, right, out of metal or clay or stone, we also use the stuff that we make to figure out how it works. And so we do cutting experiments, and we do punching experiments, and we also like to do shooting experiments. So that's what we're going to do now. We're actually going to do a test here, and we're going to compare which one is the most durable, the metal, the stone, or the ceramic. Now this ceramic has been fired, right? So it's...
Yeah, in a pottery kiln. So this got really, really hot. So it is very hot. It's not soft clay, it's very hard.
And so what we're going to do is we're going to shoot them in our ballistics area here. But when it comes to any sort of shooting, or I should say any experimental archaeology in general, safety first. So we're going to put on our safety goggles.
Safety glasses.
All right, so we're nice and safe. We also have other safety precautions here. We've got bulletproof glass here, so if something happens to explode, it won't, it'll be safe, but just in case, the rest of the lab will be safe. This is our device that allows us to shoot arrows in a very controlled way, in a very scientific way. And we have a compound bow, and you can pull this string to about 29 pounds of weight. We measure the speed of every single arrow that gets shot with our chronometer. And a chronometer basically measures the speed of an arrow. We turn on the light here, and when an arrow passes through, the light sensor down here detects the shadow of the arrow, and that detection turns on a timer. When the arrow passes over the second light sensor, that turns the timer off. So because we know the distance between the two sensors, and we have the time between the two sensors, we can measure the speed of the arrow. And what we're going to do is we're just going to fire at a wooden board today. A prehistoric person might have accidentally missed their target and hit a tree or something like that. And so we're going to see how each of the three types of arrow survive, or if they survive, if any of them survive. Let's turn on our chronometer here. Now usually we shoot in the dark. The light sensors get a little bit sort of off when we've got all the lights on in the lab. But we're going to turn it on and see if we can get some velocities today as well. So what do you think? Should we fire the metal, the copper point first?
I don't know. Which one do you think?
Let's do copper.
Okay.
Yeah, let's see. So one, you hold the stone
All
one
right.
there.
I feel like the copper one's going to do great.
All right, so it's not going to break?
Yeah, I have confidence. So you guys can kind of think about, too, how each of these is going to perform. Like, which one do you think is going to break most? The ceramic, the stone, or the copper?
I don't know. I like my stone. I'm biased towards stone.
I mean, the stone is pretty, but the copper is also very pretty.
So we're pulling back our drawstring on this arrow, the bowstring. All right, crank it to the right distance. Then we're going to put the knock, which is the part of the arrow that goes on the string, right here. Let me just line it up real quick and make sure we're right on target. Looks like we are. All right, so Michelle, do you want to count down here?
All right, ready? 3, 2, 1. Woo!
Well, that was pretty good. And no velocity as we predicted,
Yeah.
but that's all right.
Looks like it held up.
The point did hold up, but if you look at the shaft is crooked now. So even though the stone is very durable, it looks like the shaft actually broke off from the point. So let's try to take this off now, make sure that it is indeed unbroken. And this is one problem too with
It's stuck in
the
the
metal
tree.
ones. Yeah, it's stuck in the tree. You know what? I'm gonna have to use my shirt, I think, to get this out. Almost there. Oh man, it really was in there.
Wow.
So the point survived,
Nice.
but I think because it's so strong, the rest of the arrow couldn't sort of take the heat and sort of.
So it broke the hafting.
It broke the hafting.
Yeah.
So, all right, let's do the stone one now.
Okay.
We'll see how that one works. I wonder if what the kids think, if the kids predicted whether or not the metal or the stone or the ceramic survived.
I'm pretty impressed with this copper. It didn't even really bend much.
That's
so
true.
I'm pretty proud of this.
So the nice thing is, even if the copper point bends,
Yes.
it will, you can hammer it back into shape.
Yeah, so the good thing about copper is that you can quite easily rework it. I could put this back in the forge, just hammer out that tip and make it nice and straight again. And then rehaft it, so it's very durable.
All right, here we go. The stone one now.
Okay, I'm kind of nervous.
I think the stone won't let me down.
Okay.
All right. All right, Michelle, why don't you count down again?
All right, 3, 2, 1. Woo!
How did that do? All right, well, look at this difference. The haft is completely intact, but the tip of the stone broke.
Yeah.
So this is the opposite situation of the copper, right? Where the copper haft broke, but the point was intact.
Yes.
This one, the stone point broke and the haft is intact.
Okay.
So
Nice.
Yeah.
Interesting.
So a different result. Now let's try the ceramic point. We'll see how this goes. I don't know, we'll see. Now,
ceramics are pretty hard. If you think about, your coffee mug at home, sometimes you can drop those and they're totally fine because modern ceramics are very durable. I don't know about shooting it into a tree.
well, I'll tell you one thing too, is that this is much lighter.
Oh.
So this is gonna fly a lot faster than the first two arrows did.
Yeah. The copper is very heavy. That's true.
So basically, the lighter your arrow or the lighter your projectile, the faster it will go. All right, we're cranking up the compound bow here. All right, we're at the right draw length. Let's attach our arrow. We'll line it up.
Okay.
All right, so the last arrow here, we'll see how it goes.
All right, 3, 2, 1.
Good night. Now, look at this. Both the arrow and the haft broke.
Wow.
So of the three, the ceramic point did the worst because both things broke.
Yeah, and it seems like it lost a lot of the point.
It did, like it lost a lot of the tip.
Compared to the stone.
Compared to the stone and compared to, well, the metal didn't lose anything. So given that these were all kind of the same size already, we can see the costs and benefits of each material.
Yes.
With the copper, the haft broke. With the stone, only the tip broke. And with ceramic, both broke.
Poor ceramic.
Poor ceramic. And so, but I think you can sort of see from this that when we do experiments, we can actually see how prehistoric people may have made their decisions and why they made certain materials or use certain materials at certain times and other materials at other times, because there's costs and there's benefits. So, all right. Well, I think that was a successful experiment.
Yeah, I think we learned a lot. I hope you guys learned something about different types of projectiles and how durable they are. We do have a question from one of our classrooms, and they asked, why do you use the machine to shoot instead of shooting the bow and arrow yourself? So that's a great question.
Yeah, that is a great question. Sometimes we do shoot the bow and arrow ourselves. However, sometimes we want really specific scientific control where we don't want human error or someone who's maybe not as good with the bow, or maybe they don't have as good of aim as the machine does, and we need to hit the same spot exactly over and over again. So that's why we'll use the machine in that case. In some experiments, though, we don't need as much scientific control. And in those situations, then we do have a human shoot the bow. And we have different types of bows as well. So this is a compound bow, but we have recurve bows and other traditional bows. It really depends on the experiment that you're trying to conduct. Sometimes you need lots and lots of control to answer your scientific question. Other times you don't, less control.
It's more realistic. You might just want to go out and see how it actually performs, in the wild, essentially. So there's more realistic, and then there's more, I guess, scientific or lab-based studies. I do have another question for you from a student.
Let's go for it.
This has to do with flint knapping from earlier.
Oh, nice.
Do you need to know what type of rocks they are to craft different tools with them? And this is from Portage Path School.
Oh, all right, Portage Path.
Yeah.
So do you need to know the types of rocks in order to craft them or flint knap them?
Or to make different things.
Or make different things. No, as long as the rock that you're using possesses that property that I mentioned earlier, conchoidal fracture, you can pretty much make any knife or projectile point out of it. Where you run into trouble is if the rock doesn't have conchoidal fracture.
So what kind of rocks do have conchoidal fracture? Just like a sandstone or a granite or what?
So the main types of rocks that have conchoidal fracture, or they fracture like glass, are flint, also known as chert, basalt, and obsidian. Those are sort of the big three. Granite does not, rhyolite does not, sandstone does not. So there's a select few rocks that you can make your stone tools from.
Okay, so one more question about flint knapping. You guys must have really liked flint knapping. So they're asking, you used a river rock to chip the flakes off from the core. What is the best stone to use for chipping? So
what is the best hammerstone to chip your rocks from? Great question. That depends on what you're making. Usually for me, for sort of delicate arrowheads and things like sandstone are really great. That rock that I was using earlier is a type of limestone. It sort of has a little bit of give to it. It's very soft. But for other really ancient technologies, like the Neanderthals made 300,000 years ago, I will use granites, very tough rocks, to make the stone tools. So different technologies require different hammerstones. And you can also use things, like you said, like antler or even a wooden baton to knock off flakes, which is pretty cool. Yeah, that's exactly right. Yeah. So, one more question, we got another question just came in. Let me grab this. Okay, so are any of the things you find valuable? Well, so they're valuable. So the artifacts that we dig up, and we do excavations and things. The things we dig up are valuable in a scientific sense. Artifacts should not really be bought or sold or traded or anything like that. but they are valuable to scientists and to their descendants in lots of different ways.
Yeah, so they're valuable in what we can learn from them about the past. We can learn how people were making their tools, what were they eating, was there warfare, was there peace, did they grow crops, did they hunt? We can learn so much from the artifacts. So in that way, they're very valuable for knowledge and learning.
And unfortunately, the stuff we make here is not valuable.
Yeah, that's why we break it.
And that's the advantage of experimental archaeology, isn't it? Is that we can make as many arrowheads or as many pots as we want and break them as many times as we need to get the scientific answer that we're going for.
Yeah, so it's fun, and we can learn stuff and also protect the real artifacts that are in a museum.
Yeah, great question. Oh, we've got another one coming in?
Yep.
Here, let me ask this one. Here we go. Let's see. Can you use wood instead for tools? And that comes from Helen, who's a 4th grader.
Oh, yeah. So we think that some of the earliest tools used millions of years ago by our ancestors would have been made out of wood. These would be simple tools like digging sticks, just for digging, tubers out of the ground, even hunting with a simple spear. You don't need to put a sharp little rock, we don't need an arrowhead on your spear. You could actually go hunting with just the wooden spear. We know Neanderthals did that, and other human groups. So yeah, wood is really important to humans. The problem with wood is that it actually rots in the past, so it doesn't preserve. So when we're digging up a site, we usually just find the stone arrowhead. We don't find that wooden shaft part because it doesn't preserve well. But yes, wood, very important for tools.
Wood does sometimes preserve, doesn't it?
True. Yeah.
Where does it preserve?
Often if it's really, really dry, like in Egypt, we get little, even artifacts or figures in Egypt made out of wood. So it's really, really dry. Or sometimes if it's really, really wet, it gets preserved.
That's true.
Like in a bog or someplace where there's not a lot of aerobic activity, the wood will preserve.
All right, we got another question here.
Okay.
These are great questions, by the way, everybody. Does the different type of bow make it go faster or slower? So if we put a different bow on there.
Yeah, that's it. You can answer that.
Well, I won't. Okay, so yes, different bows have different weights that you can pull, all right? And the greater the weight, the faster your arrow will go. Now, that depends on the mass or the weight of your arrow. But assuming your arrow is the same weight, if you pull that arrow with a heavier bow, it will go faster. If you pull the arrow with a lighter weight, it'll go slower. So really good question. Got another one. Oh, here, Wanya, do you want to read that one?
Yep. What would happen if you used a titanium arrow?
A titanium. So to my knowledge, prehistoric people never used titanium that we haven't found yet.
It'd probably be a really awesome arrow, though.
And it would be an amazing discovery if we found that prehistoric people used titanium. But we do comparisons where we use modern arrowheads, what are known as broadheads, and we compare them to the stone ones.
And those are made out of steel.
And those are made out of steel. Yeah, that's right. And what's nice about that is the modern broadheads give us a kind of benchmark because we've been improving arrow technology and bow and arrow ballistics for a really long time. And so by using the modern ones, we have a benchmark for how stone or copper or ceramic arrowheads, prehistoric ones, could perform. So even though we've never seen titanium arrows before or arrowhead, we do use modern ones to compare our artifacts to. All right, Oh, I'm going to ask you this one.
Okay.
This is from the Arnold School.
Okay.
Can you make a tool out of limestone?
Yes, you can make a tool out of limestone. Actually, in the pottery I study, they used to add stuff to the actual clay, and limestone is one of those things that they would add. It's called temper. And so they would use things like shells, limestone, even bone. They would smash it up really small and mix it into their clay, and that made their pots stronger and more durable. You can also, limestone is used a lot for carving. Beautiful sculptures are carved out of limestone. You can even carve it into like a stone bowl. So yeah, limestone is really useful.
Oh, this is a great question. What kind of college education do you need for your kind of career as experimental archaeologists?
I mean, there's a lot of different things you can do that are useful for archaeology. To do experimental archaeology, you need to be good at science, but also liking art is really important. I actually have a degree in art that led into me doing experimental archaeology because I'm good at making stuff.
Yeah, so really science, art, mathematics, physics, even music. We've had students in our lab who were professional musicians who looked at artifacts and the sounds that they make, because prehistoric people made instruments and things. And so really that's the nice thing about archaeology in general, and experimental archaeology in particular, is that archaeology can make or take advantage of every sort of field, whether it's artistic or scientific, and it can contribute to archaeology. So really, I think our advice would be, whatever you're interested in, do it well, and you can make a contribution to archaeology.
Yeah. Another one. This is for me, have you ever gotten hurt putting the clay in the fire? Safety reminder, thank you. No, I've been very lucky and I've never gotten hurt. I am careful, and you guys should also always be careful. Clay, when you take it out of the fire, is very, very hot. Obviously, forging is very dangerous as well. That's why I wear a leather apron, leather gloves, protect myself. And we have signs everywhere to warn students about how hot, taking pottery in and out of the kiln is.
We have several first aid kits around as well, just in case someone gets a minor cut or something like that. And
I've been very careful and haven't had accidents. Sometimes you do cut yourself flint knapping because the rocks are so sharp. But the cuts are pretty minor, and the key is just to always be mindful. Where if you're ever in a science lab, whatever science lab it is, or even in an artistic studio, really anywhere,
just be safe. And if you are interested in any of this stuff, always ask your parents before you try it.
Yeah.
All right, I think we've got another question coming in here. Let's see. And I think this will be the last question just because of time. Why did you want to be an experimental archaeologist?
Well, for me, I wanted to do experimental archaeology because I loved art. Like I said, I love making things. I also love to be outside. I grew up on a farm, so I'm very used to just digging in the dirt, playing in the mud, playing with clay. I like that kind of stuff. I also love history and understanding the past and how people did things. I'm not as interested in the pyramids. I'm more interested in hey, how did they make that pot? So it just appealed to me.
Yeah, and I think for me, I started doing archaeology when I was really young. I actually started working with the Cleveland Museum of Natural History when I was 16 years old. So I've been doing archaeology now for 22 years.
You're a baby.
I was a little kid, and I think for me, while I really like excavating and learning information from actual artifacts, it occurred to me when I was in college that we could probably learn a lot more if we could use those artifacts. And the best way to use artifacts is to make your own, because the real artifacts that archaeologists dig up are priceless. And so we don't want to damage those or break those in any way. So by recreating artifacts, we can beat them up and throw them and shoot them and break them in all sorts of ways. And so I think for me, experimental archaeology was a way to learn as much about the stuff that we dig up as possible. So I think with that said, just thank you everybody for tuning in. And if you've got any questions about archaeology or experimental archaeology, our emails are available online with the Kent State Anthropology Department website. So please feel free to shoot us emails. We're happy to answer further questions, in the future. So thank you very much.
Yep. Thanks, guys. I hope you had fun.